Okay, so this is finished now. It's not the ideal amount of particles, but it's not so bad as well. So at this level, again, we are at VDP, but we are kind of getting these, foam-like shapes from the solver comes, but we are also getting these a little bit of a pattern-like emission points, and that's coming exactly from where we push the emission limits a little bit in the source. Okay, but maybe they are too isolated. Maybe they will not accumulate enough. Maybe they will not be a problem. Now, remember we get rid of the foam attribute and the bubble, so on and so forth. So we can bring this back using the depth attribute. So depth is from -8 to zero point 0.8, so it's -1 to 1 basically off, completely off the field or inside the surface field, I guess. But if you put a color swap and say depth -1 to 1, and it's going to give you something very similar to what it was giving in the state attribute, right? Now, but instead of storing 3 attributes, now we have 1 attribute that does the same. So um, I have been generally never very happy for the amount of white water that is coming out for the spray section. So that's why I end up creating this second section that does another sim to generate mist from the spray. Okay, so what I'm going to do is I'm going to drop down an attribute wrangle here. Okay, and I'm going to call isolate spray. And that's because of the depth. So if f at, and then I think I can just use depth. If depth is less than a value, threshold, let's say, then remove point from myself. So I'm just trying to isolate these guys to use as a new source. I did a mistake somewhere. Yeah, this forgetting another one. So now basically based on this value, so it's like super near the surface and just tiny above. So anything based basically just off the surface, right? So like zero point 0.1 is good. There's some off the surface splashes here and there as well, but mainly where most of the action is happening, right? So we don't need this color. Let's get rid of the color. Now, we can basically either cache this, but at this point, I don't think there's really a need because at this amount of particles it's fairly fast, so I don't need to really cache it. Um, we could, however, probably get rid of this opposite side, but maybe it will come from the other side, so let's keep it that way. Okay. Um, Now, because we used spectrum, there shouldn't be anything out of the spectrum as well. Oh, actually, if you have a look at this, and if you look from top view, you will see that there's a nice spectrum, like there's a nice camera culling that is never visible to the camera because of the padding, because it's just going to be a bow. And because there's nothing refracting, so this is just going to be, I think it's a very optimized way to kind of do the sim, and we should definitely stick to it. Um, Now, continuing, I have my isolated spray. Okay, fairly fast to load back, so I don't need to really cache it, I think, unless I do really heavy sims. Now I'm gonna add a little bit of attribute randomize to it because this is still, I think, to my taste, very uniform. We need definitely more very rich small division in the particles, and this one is just going to be like a Gaussian normal. So if I go here like this, so this is before, this is after, so we could probably do more, right? So it's really random now. Okay, and I'm going to drop a pop net, so we'll start emitting some particles. And it's going to be my mist solver in here. Okay, so dive inside, go forward to the first frame. Okay, so in spray or mist, let's say in let's call it spray. In spray source. Oh, come on. In spray source. Okay, so I'm gonna create a random mass. We could use that. So you could do this outside or inside. So we have pop force. Sorry, not pop force, pop property. Really doesn't matter in my opinion. Pop property is just like a convenience node. Pop property, but it allows you to change the values while you're still inside. So, but you know it has tick boxes and stuff, and you can use like a randomize, and this is pretty much okay. But um, well, it's per frame. It needs to be done per frame, so it doesn't matter in here or outside. So so we can keep it as this, I think. Actually, because it's gonna be calculating the mass every frame, and it's gonna give. Yeah, that's fine because this is a bit more accurate because in every frame it's going to give a random seed based on ID. If I do it outside, it's the same thing, really. Like, I don't think it's going to make a difference if I do this versus I do this. I just have to declare it though. Okay, and in here, if I go here, it's going to have a mass. This doesn't have an ID, but we can have them at position. No, times equals, so now because it needs to be equals. Okay, so yeah, that should also work. Really, there's not much of a difference, but to keep it in Houdini realm, we'll stick to it. So I'm emitting from points, not scattered onto surface, but all points. Okay, no, actually points because that's going to allow me to manually overwrite this. So I'm going to give seed is going to be, because it's going to be wedged, it's going to have a wedged value. So let's do 2 by 2. So 2 seconds with 2 seconds variance to create some randomness. The jitterbird is going to be negative, so it's going to be pushed back before it starts. It's going to interpolate floors backwards using its velocity. Okay. Attributes. This is, I set 0.5 because it was going too fast. These are supposed to be like slower particles than the leading splash, so we could play around. Now I'm going to drop down a pop drag. So these are mist, they're heavy, they're lighter particles, so they're going to get slowed down by air more. And maybe if you do ignore mass, it's probably going to generate something more interesting. Now, creating a wind here. So let's put a pop force. I'm creating a noise, and basically I'm saying based on your normalized age. So let's go. I think I put an amplitude of 10. Okay, a swirl size of 5. It's a big ship. Roughness is 5, but I did a little expression here. Times equals. So I'm fitting normalized age, which is 0 to 1, right? And I'm making that 1 to 0. So because 0 to 1 by default, because normalized, I'm just going to put fit 0, 1 at age, and age is normalized age, and I'll go 1 to 0. So I kind of like reverse this, but basically I'm saying have more effect if you're a young particle and have less effect as you're getting older and older. Okay, so it's gonna less more and more as it kind of like comes together. It gets older, it's gonna have less wind noise effect. So let's try it first. Let's see what's gonna happen. Some particles are coming, and obviously they're gonna just fall down. Let's. So I don't want to see these. Actually, I want to see how much I'm trailing. So this is obviously not enough. Let's put another 0 here, maybe. What is my number? Normally, I put like a million here for my final sim. Let's put a million. Press play. Okay. So a bit more interesting. We're getting a bit too streaky maybe, which means we need to kind of give these guys a little bit more interesting shape. Maybe it's because we are behind. What if I say go ahead? Then it's 2 ahead. What if I say 1? Okay, this is gonna be okay maybe. Now it's too random though, right? Um, it's all over the place. So I'm trying to use this node called pop interact that kind of gives a little bit of a interaction between the motion sharing between the particles. Okay, I'm gonna say ignore the mass as well. So if I press play, it's a little slow on the, it does slow down the sim, but it kind of starts making the particles behave a little bit closer. Maybe this is a bit too much now. Okay, maybe if you do a full out radius of 1. So it's a bit better, not completely random, but not completely stuck together as well. Okay, now, of course, what's happening now is that everything is falling down. So pop float by volumes comes into play here. Oops, let's save. Pop float by volumes. This thing makes your particles float on the surfaces. When I say surface, I don't mean geometry surface, but like surface fields. So pin it. Field source is a SOP, and it's out spray SDF. So what does that mean? So what I'm also doing is something a bit different. Um, you know how I did the culling in here? So my surface field is too big, okay? And I want things to collide and not go inside this geo. So what I'm doing here is something similar, but I'm doing it to my collision shape. So for example, I'm going to bring my, this is just for playing around. I think it's quite fun because you can have a lot of particles, so it could be useful. So I'm going to do an object merge, and I'm going to bring my VDB collision of the ship for this section. And we're going to do some similar culling, but this time outside. Okay, so that's my VD, not view. Yeah. Okay, so it comes down here. If you want to know the connection relationship between inside scenes in Houdini, you can go to view and show for selected nodes. And if you select, you say, yeah, I'm coming from here. And if it's coming from outside, there's a little arrow which you can right click and say jump to. Okay, and we'll go there, wherever it's coming from. Okay, so this is my now ship. Okay, now I'm going to bring my simulation here in sim. And I'm going to bring, so let's do it here actually like this. Okay, but I only need, I don't need these boxes. I only need, I'm going to put delete sub. I'm going to say keep surface and velocity only. Okay. Well, they're there. If you want to visualize them, you can say VDB, visualize tree, if they're VDBs, which they are. So you can go down like this and say, hey, visualize me the stuff. It's there, it's just not visible. If you want to make it visible, it's a surface field. It's an invisible surface field in primitives. For all primitives in Houdini, there's a primitive properties node which you can manipulate their certain properties. So these are volumes. So if you want to make your surface field visible, adjust, and you can say ISO, and that's going to give you your visible. It's going to make it visible, basically. It's the same thing. Okay, I don't need it to be visible, however. Now, actually I do because I want to see what I'm doing. Now, I have my VDB ship, and I have my VDB surface, right? So I'm going to combine these. We're going to do a little bit of VDB manipulation, okay? So I'm going to say combine AB pairs as an STF union. Okay, so now they're combined. So this is now one STF field. Okay, cool. If I look here, there is one surface. Okay, there's an error. It says some grids were not processed because there were more B grids than A grids. So it's I think it's talking about the velocity. So if I say do surface to surface, it will clean that error. Okay. Now I want to create another volume based on camera. So I'm going to drop a volume here and say I'm going to say cam wall. Okay. Now this doesn't do it from VDB, but there's a little workaround we can apply, and we're going to say properties could be that its value is 1. Let's say surface as well. If I look from here, it's somewhere there. It's too tiny. What is this? Nothing. But I can say z is 150 meters. Okay, now I have a field. Okay. Now let me see. This is fine. This is fine. I think I can change it by size. Maybe do 0.2. So this is it's a scalar. It's a smoke. It's a smoke field, but we're gonna convert that anyway. Okay, I think we could do this display mode. Maybe ISO surface. No, yeah, because it needs to be like this. It should work. Let me see. Its border type is constant. Yeah, this should show up. It's not showing up. Okay, doesn't matter, but it is there. How do I know? Then I can do drop a volume bound. Okay, now I'm going to convert this to VDB from polygons. Just don't want it to be slow. Yeah. Now I'm going to drop another VDB combine. Okay, and this time I'm going to select STF intersection. So let's select surface to surface again and do STF intersection. Okay. So now we only have what we have here, but we need some padding clearly. So I'm gonna do a little bit, maybe 100 by 100. Okay, maybe 100 is too much. Is it? Oh, no, it's fine. Okay, so our collision shape is now shaved as well. So I could do this inside the sim as well or outside. It's the same thing. I'm just showing different methods. Now, however, now if I put a VDB 3, you're going to see something that is not very cool. So this is the surface, that's fine, but I need my velocity fields too, right? So I need to bring my in velocity field, and that's coming from here. Actually, I could probably do that like this. This guy goes here. Okay, so I need to do something similar to my velocity field. And if I have a look at my velocity field, that's the old big one, because we didn't do anything about it. So we need to kind of like optimize this as well. Okay. Now, what I can do is that I have my velocity field here. This is one way of doing it. If I can just keep my velocity field and then do a VDB activate, then I can use another reference field to say that, hey, I just want to match the activation like I see in this field, which is my VDB combine 2, right? So that's going to go to region to activate. Now this is my original VDB. That is for the velocities, right? And now if I go here, there's nothing happening. So I think one way to kind of like see what's happening is this guy here. So now if I select my VDB activate and say I want to affect my velocity group, and I want to use a reference field that is my surface. And I want to activate using VDBs. I think now I want to use intersect. Okay, and now this is my velocity field. That is a good match to my velocity field. And now it is just the velocity field here. So I can merge this back to here. And now I have a very optimized collision field. This is both surface and velocity. Okay, good. Now I'm just gonna delete attribute delete. What do I not need here? I don't need any of this. I don't need the top object. I don't need any of this as well. And if I look here, I just have a surface and a velocity, and that's all I care. And I'm going to cache this out real quick now. So I can do a real fast iteration of this Miss Solver because it's supposed to have really a lot of points. So I would really like this to be super optimized. Okay. Um, so let's drop in a file. Actually, let's put a null and let's say out spray SDF. And let's put a file cache. And let's just call this spray SDF. Again, not to forget what we're writing. Load, all good. Plug it in. We're going again now to out to our where's our .NET? Okay, it seems here. So now here's the other thing. This requires the sim only, so it can still go on the side of here. Okay, because we don't use that for collision for the Whitewater. If we want it, we could just chain it there, but at the moment we are not. So I'm going to drop in a ROP network, ROP geometry output, and I'm going to call this missed SDF, okay, or missed collision. So this goes down here, automatic, pin, come here, down here. I'm going to cache this out, select your file cache node, hit P, open up the attributes output file, copy parameter output file, paste, and this is not a sim, so it can stay as it is. This can go like 10, so it launches 10 a day. 10, it does 10 frames every time. What else here? Our optimized collision mesh. If I switch a frame, it's gonna take too long. The only time, yeah, it will take too long. So you don't want it to take this long, obviously. That's why I want to cache it out. If you want to basically, we have to understand where we want to spend our calculation time. So I want to do a lot of little wedges. I want to make sure that this spray layer is correct because spray layer really adds a lot of nice cool detail. So that's why I want to have my most optimized possible way to kind of like spend less time on everything else, spend less memory on everything else, and do the most I can with my machine calculating the simulation complexity. Save, double check everything, and all good. Right click. No, not all good. Scheduler, both. And yes, that is it. Right click, cook, save. Now, when this is over, I'll come back and we'll start checking some simulation settings. Okay, so the STF is cached out. Let's dive inside. Let's do a little scrub. And yeah, it's working. Okay, our optimized collision field. Let's go down here. Yeah, let's dive back inside our .NET. So we have this field that we can call it null out spray STF field. Let's call it and drag it to here. Okay, so it has a surface field name surface, velocity field name velocity. Okay, and the first frame I guess doesn't record it. Yeah, okay, so that's correct. Now let's dive in back inside, and we could add that there as a collider as well, but I'm not gonna do that right now. What I want to do is just press play, and okay, so let's see what's happening. We don't need to see the spray source. So unlike before, things are not going to be now falling down through because they're supposed to sink and come up like there's water there. Okay, well, hence the name, pop float by volumes. Um, Now we could do a couple things, like playing with the settings and forces, and if you want to add a little bit of a drag to these guys, but their spray, and they're going to be short-lived. I believe that we change this life cycle, life length. Yeah. Okay, and if I press play again, yeah, they definitely need some more drag, I think. If I look through here, let's press play. And what's happening here? Let's see. So I'm passing through. We're gonna fix those. I guess some are getting stuck inside the ship, which I believe here we gonna get rid of those as well. So let's add our ship collision, which is we can I guess just come back here and just copy these two guys actually, so we can do the in-sim culling as well for optimization reasons. So you go down here, and let's merge this guy here. Okay, and which means we probably didn't need the ship if we're gonna introduce the ship as a collider, but should be all right. Okay, now I'm gonna call this spray. Now we're gonna do something and a little bit more interesting with our mist sim wedge test here. So this one is a sim, right? And I'm gonna do something to distinguish this from the rest of the nodes. So this is out mist source, and this guy is here. So I can just pull this up a little bit. Here, this one is our. Actually, we didn't need this really. We don't need this because we're colliding this against our ship surface anyway, but that's fine. Let's change this here like this. Let's call this mist sim. Now we're going to do a little bit wedge test. First, attribute delete to get rid of the 40 million custom attributes that we don't need. And if you guys can see, when I put a star, it's pulling out everything, right? And I definitely don't need that. So basically here I cannot just say, I am only interested in what comes out from spray. Okay. It's very similar to what we did here. You could still use import Whitewater fields, and then I'll just call it import particles maybe. So there's like several ways to do something. Both produces the same output, give or take. But if I go in solver here, dive inside called spray. Actually, let's pin it like this. No, not this one. Pin it like this, dive and say I want to use this guy. And I just want to pull out the geometry. It's just going to pull the import mist. Okay, so let's just get rid of what we don't need because there are 27 attributes here. So we're going to do something similar, just like we did above. Right now, I'm only interested in 3 attributes here, which is just age, ID. Not like this, everything but age and ID. And I don't need any of these. Okay, and I'm going to do the same thing. If any group is going to get rid of, it's pretty much similar. I should probably create HTAs here, cache simulation points, whatever. Um, and I'm going to cache this out. But before I cache this out, I'm going to do something else because I want to play with some settings and do a little bit of a test. Okay, so let's go to the top net, and you can do this with all your network settings as well. So in my opinion, this would be a temporary net until I get the values right. I'm going to call it flipbook wedges. Maybe some of you have done this in the in some of you have done this in the Houdini tutorials in the past. Maybe some not, but I think it it's a good way to iterate on caches. So what I'm going to do is I'm going to put a file cache here so I can read this back. Now I'm going to say, let's do null, out miss sim. Okay, so it could be, this could be even, I think, a more a cooler sim, which is in some of the other shots I'll show how to do it, is to get this layer advected by a volume simulation. Like it's really nicely doing something, going behind the boat when the boat actually this battleship does a little bit of a drifting, like Fast and the Furious style, and that's where I think some nice volume simulation could come really handy. Missed wedge test. Okay, so dive inside, drop in a wedge node. Okay, and whatever you want to wedge here. So I want to wedge, maybe I want to do like 10 of these simulations with different settings, right? And that could be wedging between different attributes, either to make it look busy or to make it look more um, interesting with different values, maybe different turbulence values. So I'm going to have, for example, 4 versions. Okay, and I'd like to wedge my pop interact. So I want a velocity force from, I want to try a fall off radius of 0.1 to 2. Let's do that one. So this will be int dist, and I want it from 0.1 to 2, and I want it to do like 5 sims, 6 sims, whatever. And if I do like a, generate node, it's going to give me the values. The first one is going to be 0.1. Is the last one. This is only going to be like 0.3, whatever. I can do 6 of these. Sure thing. Actually, because we're going to do 3 by 3, the 6 is fine. Now, rope geo. I call this one miss sim wedge test. We did the same thing like before. Oh, we can't do the file names like that other way because we need to do the wedge index so that we don't overwrite on our files. Okay, so they'll go under, like, wedge 1 will go 0, 1, 2, 3 under another folder. This is the full frame range. Again, as usual, it's going to be coming down to here. Okay, and then I want to do something else with this. I would like to filter these by range. So I want to do 1001, my shot range, 1075, okay? And then I want to do a GL render of this. So I'm going to do a fetch, pull this guy in here, okay? And I'm going to put a ROP network here. I'm going to put which one should I use? I'm using the OpenGL ROP. I'm going to put an OpenGL ROP. Okay, and in my OpenGL ROP, I'm going to say use the shot camera. Yes. shot camera, and I believe that's all I did. I'm going to change the probably particles to pixels. This part might take a little bit of testing, so it looks, not ridiculous. And IP output image is going to be the wedge index .exr this time, or JPEG as you require. And I'm going to go back down here, and this is my GL render. Okay, and this is my open GL ROP, GL render ROP. So I can do other things if needed. And now I'm going to put a ROP composite overlay output, sorry. And I'm going to name this wedge overlay, right? And we are going to set its settings now. ROP compositing is single frame. The resolution is fine. I want this to go in this folder. This is coming mostly from Houdini documentation. Just plenty of really cool stuff, to be fair. I'm going to do all frames in one batch. I'm going to do a manual render on the strict range frame scheduler. I would like is to be done locally because my other machine doesn't have a GPU. Okay, and now the overlay is gonna be schedulers ROP composite output. This one is cool. This one is cool. Okay, this one doesn't have the parameters. I think this was edited manually. Let me double check this one. Yeah, it's just a text. So let's do that. Right click, edit parameter interface. And I'm going to create a folder called overlay. And inside, I'm going to create a little text node, which is a string. It's just I think it's this one. Yep, just a string dropped in here. Let's call it overlay text. Oops. Overlay text. That's the name of the attribute. Apply, accept. It's over here. Maybe let's make it a few more lines. So select this guy. I'm gonna do this multi-line string 8 by 40. I think that should do it. If I come here, that's correct. Now I want to write some of these files in there. So SimForce, not the source size, but whatever attributes I'm doing, right? So I'm gonna remove this. I am gonna be affecting pop interact. Oops, too much. Pop interact distance, and that's the name of the attribute basically. So I just need to take this guy here and paste it here. No, like this. Okay, now I'm gonna partition this by attribute, which is by frame. After all, this come out to disk, partition by attribute, and turn this on. Name is frame. Okay, so by frame is going to then group these, and I think it's distinct attribute values. Yes, it is. Now image magic. It's going to do a little bit of image processing. Now, if you don't have image magic, there's a documentation on how to install this on, Windows. I don't even know if it's actually now just coming with Linux or Windows or with the Houdini installation out of the box. Actually, we can probably just see that. Let me double check. Houdini image magic. Okay, it's in the documentation. So it says provides easy access to image magic functionality such as mass image convert, resize, image mosaics, and so you can just search for this in the documentation, follow the steps to install it, and that's pretty much it for the installation part at least. Okay, I'm going to close this now. Now what are we doing? ImageMagick is going to do this basically. It's going to take all these images, convert them to PDG under the images, and that's all it's going to do basically. And finally, I'm going to wait for all of this about process to finish. And then we're going to convert it to a video using FFmpeg encode video. It's going to take the frames coming from up. I don't even think we need to change anything. Output file path. I did change the file path. No, that's not the file path. This is the output file path. Yeah, that's the same. No, I just changed it under the videos. Okay. Do we have videos or video? Let's check. Let me double check here. Where does it work? Projects, Battleship, 10. We have video, so not videos. Let's call it video so it doesn't create an extra folder for us. Frame list, yeah, I'm just gonna put it here because in its own location anyhow. And I guess I'm just gonna save this now and do a little generate node to see what it's gonna do. So it's maybe it's because you didn't find them, or let's go one by one. Oh, this is filter by range. Is this the filter by range, or did I run the range? Oh, I didn't put the correct range here, I guess. This is gonna be 1001, 1075. Okay, now it generated the necessary jobs, which means this guy is going to render using the, this guy here. Unable to find the rope node. Good flag because we didn't edit. Let's add this guy here. Perfect. Regenerate. Now basically, if I right click on one, it's gonna say I'm gonna create this thing. Okay. Generate node. No error. Similar number. That's fine. Generate node. This should work, I believe. That's gonna divide this into chunks by attribute. Let me see. That's frame. Okay. And then it's just going to convert it to a video. Hopefully that's going to work. I am a bit skeptical that it's going to work out of the box at once, but let's not forget to connect our attribute integer distance to override our pop interact fall of radius. That just goes like this. So it will do it properly. And then once maybe if you like something, then we can go back and just wedge the amount by jittering the seed. So we have plenty of cache to follow. Okay, and save. Right click. This time I'm just gonna make sure that the schedules are correct. Missed which speed test. So these are simulations. I can send these to both of our machines. Filter by range. Oh, good. This needs to be local. Actually, yes. This can be. I'll make this local as well, so it doesn't switch. All good. All good. This could be local as well, because I don't think I installed the ImageMagick on the other machine, so it doesn't error. This will do it in the local machine as well. Okay, let's cook for real, and then we'll see once this is done. Okay, let's pause the video. Okay, so this top network ended up cooking, although one thing that didn't work for me was the image magic, and that's most likely, I'm guessing, because image magic executable file lives outside my uh, like I think Tops just couldn't find how to process it, so instead I removed the scheduler, so it actually worked as a local task on this machine as opposed to sending it to HQ, and that kind of sorted out the problem. So what it is was, if we observe now, first it took. Just want to reiterate. Let's pick a slice. Okay, so it did change the value to. So this is generating a value, right? 0.1, and we want to test the traction force distance, right? So, and then if you click on this second one, it's going to show you the other one, and if you select this guy, it's going to show you the other one. If you select, the last one, first one, so on and so forth. Like if the traction force is too small, I think you get more separated particles. If it's the highest, you get a bit more tight. And since I was going to pick one, then I realized I think it's better if I just wedge these and render them all together. That will probably look a bit more interesting, but feel free to keep testing. Now, what this does is, if I select one, so this one seems based on distance, right? And this one, oops, creates a filter by range. So from, if I need to select this guy, it splits all these, it groups them based on these frame ranges. Now this one renders those based on these frame ranges, 450 of them, frames, using the OpenGL ROP, basically just as a screen capture of whatever is visible here. Okay. Um, on how this is going to look heavily depends on your individual settings. On OpenGL ROP, I advise doing a little bit reading. Sometimes the results are not very similar. Like, you want to change the particles to pixel, you have to do it here, not here, so on and so forth. Now, then the wedge overlay, this one didn't work. I need to investigate why, because it was supposed to paste this down, but I guess we skipped a step somewhere. Wedge overlay, maybe I haven't seen it, but I guess I skipped it somewhere, or it just didn't work. Anyhow, this was just to put, this is actually quite important because it tells you which, you'll see where it falls down. Um, Image Magic is the one that converts all these to, merges them, and then like it does a montage and then pastes them as PNG, and then everything, all these frames finishes, it makes a video file out of it. So what does that mean is this. So if I go here under the video, it kind of generates me something like this. Okay. The problem with this is that it actually didn't put the overlay, so I cannot figure out now which one is which one. However, then when I watched this, I was like, hey, this doesn't make much different. They all look similar. So I decided, because the original goal was to, figure out a better sim variation, so on and so forth, and then render it and then wedge that one. But instead, I decided just to load them all as one wedge to cache them out to render. So what that means is that I'm, instead of loading them one by one using wedge index, I'm using a file merge, and a file merge basically can figure out. So if we go here, if we go to that path, if you guys haven't used this before, geo missing wedge, and you can feed it a file pattern, and you can replace the pattern like here 1 2 3 4 5 with an attribute. So it's dollar $slice, and I say 0 to 5, load them all together for me, and it just kind of loads them all. I think there's a loop inside. Basically it just loops in. Okay, and what else? Then I'm converting this to a convert to points. Okay, so we have these guys here. Now what are we going to do before we finish the effects? The cache creation is, there's 2 steps left, is to outputting Whitewater as RS proxy and outputting the mist as Redshift proxy. So before we skip this step here for a reason, because we need to do a little bit of a deformation in case these particles reach the edge of the tank, because we did compress our simulation edges to be flattened. So I'm going to put an object merge here because I do want to gather my geo right after the attribute transfer of the fall off, but not right before we change the edges and right after we transfer the fall off attribute. So that's gonna be underwater sim, because this is not what we are rendering, right? We did this, okay, which means I assigned a little shader there, so I'm gonna turn it off. Which means that I do want, because my Whitewater will be following this shape, right? So I'm just gonna transfer this guy here because I'm essentially rendering, let this cook, because I cooked the flip proxies before, right? I'm essentially rendering this. Okay, so if we go here, and turn on our lights, I guess. Right, this is our water, and it kind of is jumping out now because we are not visualizing, we're visualizing the step before. Okay, now we're visualizing the geometry, deformed geometry against the particle. So let's do our work on the Whitewater here. I'm gonna visualize this so we can see it as well. So here is our original geometry that our Whitewater is resting on. Everything inside is foam. Now we're going to attribute transfer the fall of attribute using the same distance here. Let's just copy this. Actually, let's just copy all of this pretty much. All of this. Okay, and actually let's just copy all of this. That's because if we need to deform the edges, okay, copy. Let's go here. Let's paste it. Now fall of comes here. The particles to the left are fall of attribute from the original sim to the right. Okay. Now let's do, I think this one is not gonna work out of the box, so we probably need to modify this one. Actually, I don't think so. Let me see now. We should have the fall off, so let's do a color swap. Okay, so we have a fall off here. I want to make sure that it's correct. Okay, and then we should have it on the particles. It's not visually out because this is still packed wrong, so we need to do that. Okay, so we had the fall off. So this part's supposed to come down so it conforms. And if do I need to do any modification? No. So now it sits. I basically just copy pasted the same thing that we were making this fixing for pulling down the edge of the geometry. Apply the same technique to the particles, and that's also now resting on the geometry. So if you look here, we will not see floating ones, but if once we render, just want to be careful with this one because the blur might require not based on connectivity but proximity, because they don't have because particles are not connected to each other, so by default influence type by connectivity is not gonna work. So you may want to change that. Okay, I want to visualize spec mount because that probably won't work, but we probably should because our spec mount is calculated based on vorticity as well. So for this testing purposes, I'm going to copy vorticity also, but not the speed. Now, because we don't want to change the original speed of the particles, we're going to probably need to change the name from V to something else. So let's say, no, actually, keep attribute. I don't want to completely rename it. I actually copy it, so I'm just going to say attribute wrangle. Okay, we're going to say V at temp V equals at V. Now, why am I doing this? Because I deformed the mesh using its V velocity values and vorticity values. But particles might be doing something else, right? So I don't want to manipulate some of these particles that way because they have their own velocities because they're doing some different things. So what I'm going to do is that I'm going to transfer this temp velocity. Okay. Now, if I look here, now we should have vorticity that is similar to what was available on the water surface. Now, here instead of measuring the length of velocity, I'm going to measure the length of temp v. Vector temp v. Oh, no. Was it the name? Or am I telling a typo? That's correct. So come here. Okay, so now it's the new one. This one is same as the mesh. Now this one is same as the mesh as well. Doing the same math and applying the same amount of blur. So I'm looking for speck mult now. Okay. It's blurred out. And if now I'm going to apply the distance to the speck mult, okay, there's a little thing we need to be careful around here. So this is going to apply, if it found any particles around this area, it would deform them as well, so they will fit. But we just need to be careful. We're just not reaching there because we don't want it to be using these areas, but I think we should exclude these. And we don't have the groups, but we have the depth attribute, I believe, still. So we should only make this work if these are not spray, just in case, okay? That means, let me see if this is getting deformed here, right? It's getting deformed, but it's off the surface, right? So we don't want anything to be affected if they're off the surface, which means that their height value their depth value is bigger than 1. So we can do a little if condition in here. Or we could group them based on if condition, apply this to the group. So several things here. So this is the part that I'm deforming, right? So I can say if compare, and I'll bring the depth attribute. Did I bring it here? No. So I'm going to say bind. I'm going to bring the depth attribute in here. And then I can say, basically, I want to return, because this is my multiplier, I want this to be 0 if the condition is correct, right? So I can say depth here, this goes here, that's going to be a multiplier, and then greater than, so that's going to return an integer, and I can say maybe multiply my value that's not wait, if that's not true, if no, I don't need this. Oh wait, this needs to go here, and I don't even need this because I know that. No, actually, compared to float, no, we need to the depth. This goes here. Yes, is greater than. Let's see if I put one. Everything in here. So my if depth value is greater than 0, it's going to return a 1. If it's less than, it's going to return a 0. So, okay. In this case, everything snaps, I believe. So I'm going to say greater than. Let's double check if it's affecting it now. No, we need to check the spec mount value, the output of the spec mount. This is, okay, I'm trying to get, let me make this a bit bigger so we can see it a bit better. Geometry, points. Okay, so I want anything that is a spray not to be affected by this. Actually, we need to fix this as well. Okay. We got the vorticity. Okay, so anything, because the distance here is not long enough, I believe. That's why the bottom is getting affected. So we just want this to work on the foam. I think it's going to be easier if we create a group here on depth attribute, and we'll call this foam. And if depth is, I think it's going to be even easier if you do it by color and then choose the color to be the group. So let's go ramp by depth. That's -1 to 1, right? And if so, we want to select. No, this come here. You are black. No, you are black, and you're also a black color. So that should give us the range of Whitewater. So let's maybe adjust that a bit better. Okay. So we can use that probably as a multiplier. Okay. That's gonna close, not so close. Okay, so I'm gonna convert this to another value, maybe f at spec effect deform malt, let's call it, equals at cdx. Okay, I could probably use that in here as well. That's still okay. Now this is already on here, so now let me see. Um, okay, let's bring in. We don't need this anymore. So what I'm doing here is I want to visualize this first because it's confusing me. Let's go in here, remove the colors. Okay, let's dive in. So I have my fall off. Oh, this is my fall off. I don't need to do anything with this. I should have done it with this because this is the spec multiplier. So this was wrong. Maybe we are doing the wrong thing, right thing, and then we end up doing the wrong thing. Okay, doesn't matter. We can do it again. So let me put this color, so the output to CD here, so I can see what I'm about to manipulate, right? So what I don't want to manipulate is, well, that was almost correct. It's just the values were a bit off. Okay, so there's just a bit of a contamination of color here due to using the attribute transfer, I guess. Now, because we have a bit better representation of the attribute that we just created, which was deform malt. So let's plug it in here, bind deform malt. I'm gonna just plug this guy here. Okay, and I'm gonna make sure that, where is the R value? I guess we could multiply the output here. 1 second. Okay, so this is my deform multiplier. That is just a foam. Okay, I'll probably need to come back to this because I am not entirely sure, so I don't want to waste more time on the recording. But right now, I think even then, we are not that off because it's just that small parts there getting affected, but they will land on the water. So I think it should be okay. I'm a little bit concerned about these individual waters areas here, but I think with the when we merge it with the file merge for the mist, I think that's gonna cover that area nicely. So let's go back to pixel view. Okay, I don't need this. This doesn't need normals. Let's do a little bit of an attribute cleanup. And I'm just going to copy these based on, so I don't have to redo the attribute delete. Okay, come here. So storing age and p scale, converting this to a particle system. Here I'm just creating a default p scale value, and I'm calling this out Whitewater, and here's an RS proxy for it. Let's make sure that it's the correct output path. It's not like this. I'm just gonna use the same path as this guy here because it's using, maybe it's the same one actually. And it wasn't. Okay, it's because using the name. Now we're gonna do the same thing for the spray, which is this guy. Convert the points. Okay. Um, I believe that's right. Straight ahead, the exact same settings. I'll spray, and this is going to be spray RS proxy. Okay, now let's just create their proxy meshes. So this one is, so I'm going to create two geometry nodes. One of them is this one, but I'm going to put a little wait for all. Actually, let's double check. This is going to be Whitewater Sim. I never dived so much into these tops as much as I should have, but I want to double check because usually what I'm trying to do is to only bake 75 frames of the Whitewater proxy while without waiting for the incoming uh, node, which has 176. And when I set the auto it's just gonna go like 176. So there has to be a way to smartly just export what's required, because then if what's gonna happen is then while this is baking, as the frames finish and as they reach to 1001, the aspects will start kicking in. Only, of course, if you have available computer. But for now, let's add what we need. Come on. This is RS proxy, because you need to have one machine that has the Redshift license for this to work. Otherwise, it will fail the other machine with no license, I believe. Oh, not wait. Oh, this is supposed to be rob fetch. Okay, come here. Call it Whitewater proxy. Uh, frame range. Maybe I can just. I'll try it now and we'll see. Just need to obviously. I don't want to reread the Whitewater flip. I want to read this guy, not this guy. I want to read this guy and dive inside. Let me do a. So if it's set to frames automatic, and if I right click, generate, save. So it's oh don't generate new geometry. This sometimes happens. Sometimes it doesn't read it. So what I'm gonna do is just I'm gonna first make sure that I have my Whitewater sim, because it's trying to see if the files exist. Oh yeah, that's no, the Whitewater files do exist. They are here. So yeah, sometimes this happens. And it says I'll try to cook this. So what I'm gonna do is I'm gonna close Houdini and open a new Houdini and open this file. And when I try to say generate, I think it's gonna find them. So if you know that you wrote it, don't rewrite it. Don't continue. So it will not start rewriting your old files that already exist. Right. So I reopen this one now. If I say, for example, cook, find all the way to here, it should find the files. Oh, actually, with RS proxy, you may want to tell the system to skip existing files. Okay, brilliant. It didn't find. It did find this one. It should have found, maybe if I do it here, but I do have the files. So, okay, I'm not just going to run it because they're there. Oh, maybe it will. Okay, so that's normal. Yeah. It will find it because it just needs to open Houdini, and then it will say, I opened Houdini, then I found the file, because it's a fetch, so it doesn't have a history of the PDG. Okay, so this one should work as well. Let's finish. Let's wait for this to finish. Okay, so it did find the files. Good. Now this one found the files as well. This one won't, but I'm gonna do a generate now. So it's 176. So my goal is to not add here a wait for all. Worst case scenario we will, but let me try changing the frame range, then maybe it will work just fine. That's gonna be 1001. Generate. No, it's still doing the frame range automatic. Okay, so maybe I go frame range, but then I don't want to do one frame for one wedge for 176 frame for each one of these inputs here, which might end up being the case, which it did. I guess then it will have to be a ROP node maybe. Let me try the ROP node one. Let's set it up correct to see if that works. Let's save the streak as well, just in case. Let's go back up here. Let's try again. Oh, don't break anything. Okay, I think I'm gonna just drop it. here one and just call it a day by saying frame range 1001. I'm going to reopen this guy again because it will try to cache again, I think. Okay, let's do the mist output. Now, here's the thing. We did test the mist with the full frame range on Flipbook Wedge's top network. So we kind of need to carry that over to, let's put this here. So this is a test section to our network. So because we didn't build that yet. So what are we going to do is, because I'm using wedges, so I'm going to call this in mist wedges. So my output path will be different than my input path here, unlike because we were copying the advanced section. Remember, we don't have to do that here because we're using a wedge. Now I guess we can just copy this part into our guy here. Now this one requires Whitewater sim, which means, and it requires the mist output as well, which means we need a merge here before we can run any of this. Okay, because it has two dependencies: a simulation of Whitewater and a cached collision mesh. It doesn't need anything else, and I guess then we can call it finish. So this needs to finish, not really, because you're doing the full frame range, and but we are storing the only the output. Now that's fine. Okay, because I'm not interested in, because that's my last cache that I'm only going to end up rendering, so I'm not interested in my pre-roll, so I don't have to store it. It can stay in the memory. So I'm going to put a wait for all then. Okay, which means I'm going to put a wait for all here. Now this is looking for the SOP here, Whitewater sim, this one here, and this output is now matching the file pattern here. So it's missing wedge, version 01, wedge index. Instead of wedge index, we're using the dollar slice, and that should work, except we think we probably could do one thing, which is we could say, so wedge count is, it's saying I'm going to do 6 wedges, but the actual value is written onto this guy 0 to 5. So you can copy this path if you want to kind of like link that in efficiently. You can say then, not here, back to the readers, we could just paste this here and do a -1. Okay. So this will be always up to the correct value. Now then it's going to read it, and then it's going to output a spray proxy. So let's set that up as well, which means another wait for all. I'm going to copy paste this. Let's call it mist rs proxy 1. Same frame range, just need to make sure that it's pointing to the right drop. It is this one, spray rs proxy, and this should have its file. Oh, this is pointing to out. Yep, spray, and this should be all good now. Now, the only question is it going to find the files? Let's try. It may not. it didn't. And if it doesn't, oh, it's even trying to do it from all the way from scratch. Kill it. Um, let's pull this down a bit more. Okay, I think, and if you put a merge here, we could even chain them, chain a network down here saying, send an email, finish the shot, made a daily, have a look. If you like it, good. If not, move to the next step. Out. Let's call it out BS0010. Okay. Now, basically, because we're building a rig that we can use for all the other shots, and this kind of is a first step to solidify the setup. And in a scenario like this, we can use the setup probably in like 5, 6 different ways. The only customization we need to do here is the bounding box, which we could probably automate as well. Let me just close this again because I do want to see the result. I'm going to open it again. And if I need to rerun this, I'll rerun this to prove that it can work out of the box. Let's go to BS10. Oh, not this one. So this is like my, no, it's the correct one, yeah. The difference between, I think, the my actual network versus the current network is the current network is a bit more, I guess, solid. Okay, and more efficient. So if I'm just gonna go one by one for this. Cook network, save, yes. I found the files. Cook network, say yes. I will find the files. Cook network, yes. This is all good. Now here, yes. This is all good. Are you gonna find the files? I'll be more happy if you did. Yes, it found the files. Now these did exist. Let's save, yes, continue. Now it will find the files. Basically, not the PDGs find the files here. The RS proxy node will find the files and it will say, I found the files. And you told me to skip if I find them. And that's what it's going to do basically. I'm going to do the same thing here. Same thing here. Okay, now I'm going to cook these two as well. And the next video, we'll start setting up a little render scene. So ideally, we could plug that at the bottom as well, and then just set up some values, change some values, press one button, and you get the whole thing. And ideally, that will be the goal for how to get the remainder shots, apart from a couple which requires a custom setup. Okay, so I'm going to save my scene now finally, and I will let this cook for the remainder of the. But it just keeps forgetting. Maybe there's a bug. Maybe we should just reach out to side effects to kind of like, hey, why is this doing it? So I'm just going to go back here again, open it again. I'm just going to try one more thing. If it doesn't, I'm going to disconnect it and bake the shift proxies manually. So what if I do this? Okay, so that should work then. So it will skip all these and then it will actually cook this because we haven't made them yet. Okay, let's double check. So make sure we're not overwriting anything. It's going on the spray, and this one is going WW. Okay. Okay, so we could maybe, because this is the main sim, so we could do, and this is the Whitewater. Actually, this is the Whitewater section. No, this is coming down here. This needs to go up. If we're gonna split some of it, no need. Okay, we can just leave it as it is. I want to put some colors, but we could. So let's just put this guy here, say Whitewater. Let's put this here. This is the mist. Okay, and actually this is the flip. These are the RS proxies. And that's pretty much it basically. So we could give them a little bit color as well maybe. So this one is white, this one is gray, brighter white, this one is blue because it's water, and this one is related to render, so I keep it black. And okay, so a little bit more pretty. Let's make the white water light blue. Okay. All right, and I'll see you in the next lesson. Thank you for watching.